Calculus. Differentiation using the general formula. So if y is equal to ax to the power n, so if this is the equation, then we can differentiate that one. Derivative, it's the same as differentiate. That's the way it is. So when they tell you to say find the derivative or differentiate, it is one and the same. So y is equal to ax to the power n, where a and n they are constants. Then the derivative is going to be dy dx is equal to. So there are two things there that we need to do. Number one, we need to multiply this index with a. So any, which is the index, times a x, then you reduce this n by 1. So you say minus 1. So that is the general formula. So that's how we can differentiate. Okay, examples. So the first example is find the derivative of y is equal to x to the power 2. So remember, we are saying dy dx is equal to, so we are going to multiply these 2 with x. So 2 times x. Then we reduce these 2 by 1. So 2 minus 1. So dy dx is equal to 2 times x, it is 2x. Then we say 2 minus 1, it is 1. So remember that x to the power 1, it is x. So my final answer is dy dx is equal to 2x. That is the final answer. Part B, find the derivative of y is equal to 2x to the power 3. So remember, the first thing that we need to do, we need to multiply this power with these 2. Then we reduce 3 by 1. So dy dx, we are differentiating with respect to x. So it will be 3 times 2x to the power 3 minus 1. Dy dx is equal to 3 times 2, that is 6. 3 minus 1, that is 2. So x to the power 2. So this is our derivative. So part C, y is equal to 5x. So remember that this 5x, so it means that this is x to the power 1. There is 1 there. Okay, so I'll say dy dx is equal to 1, there is 1 there, times 5x 1 minus 1. So dy dx is equal to 1 times 5, that is 5, x 1 minus 1, that is 0. So remember that any number or letter to the power 0, it is 1. So 1 times 5, it is 5. So dy dx is equal to 5. Okay. Then part D, y is equal to 7. There is no x here, but we are differentiating with respect to x. So this, it's the same as y is equal to 7x to the power 0. Remember that x to the power 0, it is 1. 1 times 7, it is 7. So I'm differentiating with respect to x. That is the reason why I have added x to the power 0. So I'll say dy dx is equal to 0 times 7, 0 minus 1. So 0 times anything, it is 0. So dy dx is equal to 0 times anything, it is 0. So that is the answer. So remember that differentiating a constant, it is 0. Okay, so we were just proving that differentiating a constant, it is 0. But y is equal to negative 1 over x to the power 2. So we are differentiating with respect to x. So now I want you to get this point. When you have a to the power negative m according to indices. So we are going to change this negative, we are going to change it to positive by saying 1 over a to the power m. So a to the power negative m, it's the same as 1 over a to the power m. So 1 over x to the power 2, it means x to the power negative 2. So y is equal to this negative, then I'll say x, then I'll say negative 2. So this one, it is now this negative. So I'll say dy dx is equal to negative 2 times negative x, negative 2 minus 1. So dy dx is equal to negative times negative. It is positive, so we are going to have positive 2x. Then negative 2 minus 1, that is negative 3. So now I'll simplify my answer by saying dy dx is equal to this negative, it is going to be positive by saying 2 over x to the power 3. So that is our answer. Part F, so t is equal to 3s to the power 2 minus 2s plus 5. So I'll say dt ds, I'm differentiating with respect to s. Say 2 times 3, that is 6. 2 minus 1, that is 1. So I'll not write the power of 1. Then this is power 1. So 1 times 2, that is 2. 1 minus 1, that is 1. So it will be AC to the power 0. Remember where we are coming from. Okay. So, which is just 2. Differentiating a constant, it is 0. So I will not write a 0. So this is the answer. Example 2, find the derivative of a, y is equal to 3x to the power 3 minus 2x to the power 2. So we are differentiating with respect to x. So I'll say dy dx is equal to, we differentiate 3x to the power 3. So remember two things, and remember where we are coming from. So 3 times 3, that is 9. X, 3 minus 1, that is 2. So that is the way it is. So we differentiate also this term. So you have to be differentiating each term you differentiate. Each term you differentiate. So in this case, we've got 2 terms. So we have differentiated this one. Let us now differentiate this term. So 2 times 2, that is 4x. So 2 minus 1, it is 1. But you don't write the power of 1. So that is the answer. So part B, S is equal to t squared minus 3t plus 4. So here we are differentiating with respect to t. So I'll say ds dt is equal to, each term must be differentiated. So I'll differentiate this term. It will be 2 times t. It is 2t. So 2 minus 1, it is 1. So I'll not write the power of 1. So here it means that there is power 1. So 1 times 3, that is 3. Okay, so 1 minus 1, it is 0. So t to the power 0, it is 1. So there is no need for me to write there. And differentiating a constant, it is 0. So that is the answer. So part C, differentiate or find the derivative of y is equal to 3 over x minus 1 over x to the power 2. So there, remember where we are coming from. So 3 over x, it means it is 3x to the power negative 1. So in other words, this is power 1. Okay, so 3x to the power negative 1 minus 1 over x to the power 2, it means x to the power negative 2. That's what it means. So remember the first examples. So 1 over x to the power 2, it means x to the power negative 2. So this one, it is the negative. Okay. So here it means 3 times 1 over x, and this x to the power 1. Okay. So now we differentiate by saying dy dx is equal to negative 1 times 3, negative 3, negative 1 minus 1, that is negative 2, negative times negative, that is positive 2x. So negative 2 times negative x, that is positive 2x. Negative 2 minus 1, that is negative 3. So I simplify my answer. So dy dx is equal to negative 3 over, so this negative, it will disappear, so it will be x to the power 2 plus 2 over this negativity will disappear, so it will be x to the power 3. So you can try D and send your answer in the comment section.